So this project is related to advanced concepts for edge-emitting light source or to photonic integrated circuit coupling. So in this, basically, I have written this complete paper to publish in different environment in the platform of WiredWhite platform. So basically, this paper presents the efficiency studies the edge-emitting lasers within the photonic integrated circuits and highlighting their superior beam quality and higher output power for effective optical coupling and integration. It also addressing the connection challenges in photonic integrated circuits with the die to wafer, D to W basically bonding is spotlighted as well as it provides the alignment of semiconductor devices like EEFL basically edge emitting lasers and CMOS sensors basically. And next one is it also provide us the more suitable for high output applications compared to vertical cavities, so surface emitting lasers with the different precision alignment bonding structure. Okay, so I have written the complete abstract with the introduction. Like introduction, I have added like how we can use light detection and ranging of distance metrology, like how we can use this lidar system into photonic devices and how we can use this in complementary metal oxide semiconductor platform. So this is basically the introduction with the complete photonic integrated systems, integrated circuits explanation, and how it's uses in different environment, how it uses in different core diameter of about 10 micrometer and 125 micrometer as well. And yes, then I have addressed its complexities with the CMOS with D to W bonding process, utilizing advancing pick and place flip chip bonders and different environmental environments. Okay, so basically, it also contains the emphasis on basically EELs in the research is driven by their superior beam quality and higher output power, which are beneficial for efficient optical coupling. So basically, I have just explained die to wafer like D to W bonding with the pivotal technique in the semiconductor industry as well. So this is basically the electric bonding, like how the electric bonding is presented in this structure. See, this one is a electric bonding, aortic bonding basically. We call it aortic bonding as well. It provides us the different temperature levels with the silicon value of silicons as well. Okay, and this provide us I have just explained the aortic what is aortic bonding in different AU and gold tin system basically, and what temperature levels it requires to heat to develop its to change its properties to develop its bonding applications, 3D wafer bonding applications. Okay, and next one is basically I have just explained how adhesive bonding structure developed in CMOS chip, and yes, this one is adhesive bondings, which contains the on-it in tag wafer with the energy losses as well as the intensity of uh, beam basically. Okay, so next one is basically I have added the hybrid die to wafer, basically hybrid die to bonding, like how its transformative techniques for packaging the photonic integrated circuits, as well as this method basically alignment of challenges between fibers and photonic integrated circuits, like we called it PICs in short form. And it also provide us the feasibility of molecularly bonding indium phosphide and everything. Okay, you just read it, you will understand what is the actual representation of this paper. Okay, so this graph presents the comparison of bonding temperature bonding forces with the temperature and bonding forces associated with the various hybrid D2W bonding techniques. And basically I have just explained like how the bonding techniques with the temperature and forces are aligned each other. And then the passive alignment for flip chip assembly, which is basically there, which contains the pick and place process laser with the laser waveguide. And this figure basically explains the coupling of edge emitting lasers, EEL left, and the coupling of vertical cavity surfaces emitting lasers. Basically this figure right side explains the coupling of vertical cavity surfaces and emitting lasers, and left side of the figure presents the coupling of edge emitting lasers. Okay, so I have just added and written the complete nickel pads and AUS and solder, and everything is in this structure basically. Okay, next one is superiority of FLs over VCS, basically vessels, which we called it vertical cavity surface emitting lasers. And this figure contains the effect of misalignment and spatial alignment. Okay, spatial alignment. And this figures contains basically this is the output results of contains the effect of spatial alignment offset on coupling efficiency. Okay, so I have explained again these algorithms in this section. Next one is experimental and simulation analysis, which is basically contains the waveguide coupler design adopted from different research papers. And we called it Zoo, and I have just added the reference as well. So design methodology is added here, like how we have designed this complete structure for waveguide coupler design. These are the table used for the Fabry parrot laser diode parameters used in it. And next one is Fabry parrot laser design. Laser design is also added in terms of schematic representations of models Fabry parrot semiconductor laser. And the next one is normalized fundamental propagating mode pumped at 1.55 micrometer per 50 fs, like wavelength of framework. And then the results and discussion added in it in this section, which is contains the effective index plot indicating the stable mode confinement over the central 1550 nanometer wavelength range. And next one is it provides us the cross section of rib waveguide with parameters of core width, core trench height, okay, and the maximum height waveguide width as well. Okay, next one is the coupling efficiency and alignment tolerance investigation. I have just added is the E intensity mode profile cross sectional waveguide. And next one is theoretical and experimental alignment tolerances between the fiber and the waveguide as well. Okay, so these are the output graphs for the calculated coupling efficiencies as a function of lateral X and Y positions as well. Okay. So at the end of I have just written the conclusion and the references. Okay. If you need to ask anything, you just ask me. I have just added its project files in this case. You can also get that project files. Okay. Thank you.